Thank you, everyone, for joining us on the Cloud Native Islamabad workshop. And today, what we are covering, let me show Istio is a service mesh, a component which let you take control of the network communication between your application services. You can manage traffic routing, security, telemetry centrally without changing code or configuration. This workshop explains how to get started with Istio by incrementally adopting Istio and observing the benefit that Istio Service Mesh brings to you. We will be exploring various function and benefit that Istio provides to your organization. We cover the following topic in this workshop: install Istio, secure services with Istio Ingress Gateway, add services to Mesh, secure inter-services communication with Istio, control traffic. This workshop is intended for developers and operators. Anyone responsible for the delivery of microservices will find the workshop valuable. We assume you are just learning about Istio and Service Mesh. So I'm your host for the today's workshop. My name is Saim Safdur, and I am the co-founder of Cloud Native Islamabad. And today I am joined by Mourinho Vijay from the Solo.inc as a developer relations and advocacy. Thank you, Mourinho. Just introduce yourself and then we start the workshop.
Yeah, absolutely. Simon, thank you so much for having me. Hey, everyone. I am Marino Wijay. As Simon just mentioned, I am a developer advocate from Solo. Solo, what we do is a lot of application networking around API gateways and service meshes. While there are a lot of technologies out there in the cloud native world and in open source, sometimes you need some help doing it. Like sometimes you need some guidance getting this into production, and trying to do this all by yourself is always going to be fun and challenging, but that's why Solo exists. Today, we're going to dive into a workshop, and y'all can follow along. Simon, I actually have a link to share with everyone. I'm wondering how I can share that. Can I
You
actually?
can send it to me by the private chat, and I will
Okay,
share that on the comment section.
excellent, excellent. So the link that is going to be shared, I want you all to go to this link. You'll have to register. But once you've registered, you'll have access to a lab or a workshop environment. This is the instruct environment for getting started with Istio. It's a sandboxed environment where we're going to play around with Istio, deploy it, get it running, and even deploy an application that we can back onto the service mesh. So everyone will definitely need to go click that link, register, sign up, and then once everyone's ready, then we can begin. Or I will have my terminal open as well, so you all can see what I'm doing. I just won't have the instructions pane open. I'll just have a terminal. You will have an instructions pane available to y'all, so that you'll be able to either take it at your own pace. By the way, access to this workshop, you'll have it for 3 times, so you can do this all with me right now, and then you'll have 2 additional tries right afterwards that you can take. Just so that you can firm up on your understanding of the Istio service mesh. But let me get started. I'm going to go ahead and share my screen. And let's see, present, share screen. And I will choose this window. And now you all should be able to see this. Simon, can you confirm that you can see this?
Yes, absolutely, absolutely. So
Excellent.
you can start now.
Excellent. Perfect. Okay. Well, hello, everyone, again. Again, my name is Marino Wijay. If you want to follow me on Twitter, or if you want to reach out to me and ask me questions, you are more than welcome to. I'll leave my contact information up there. By the way, I operate freely in the community. So if you ever have any questions, one thing I do ask is ask it for everyone, right? It's one thing to learn and gain something, but if everyone can gain and learn something, even better. That being said, we are going to do a workshop today. Now, once you do complete the workshop, there is normally a question and survey component with it, but I'm actually going to share another link with you to be able to get to that. Once you take the certification, it's only 10 questions about Istio. You will be presented with the badge, assuming you get 80%. We won't do it here for the sake of time, but you will have access to this after our session. Now, let's get into microservices for a second here. Microservices themselves individually are amazing to use because it allows us to create applications very minusculely. We can incrementally add things to our applications. We can change things out without impacting the underlying application. We could do a lot of different things. We could do blue-greens, we could do canaries, only because we have these small little units that we're working with that form our major application. But there are some problems that arise when trying to operate microservices at scale. One of the biggest challenges is how you secure these microservices so that you can encrypt the traffic that leaves a microservice going to another microservice. You can identify who these microservices are. You can also provide the most intelligent routing to these microservices so it's optimal, especially if you might be coming from a particular destination throughout the world and you're trying to reduce your latency to access that application. There's also another set of inherent problems like trying to understand if your applications are performing in a healthy manner. So how we go about solving this is using something like a service mesh, because now we're programming a lot of the network logic where we see a lot of these problems into another layer that is, I would say, when from an application standpoint, they don't know that they're using this layer, but they are. They're using it. They can freely communicate with other applications or services and do so using this service mesh layer. Now, a service mesh layer provides three key components. The observability component, so we can see who's talking to who and what they're doing, and if there's any sort of latency between, let's say, a request and a response. We can secure, like I previously mentioned, and we also find ways to connect to these microservices. But in order to connect to these microservices, we also have to know where they are, who they are. And that comes from this concept of service discovery. So that's one of the biggest features of service meshes. They provide service discovery where you have a control plane that is able to tell you where a service you're trying to communicate with lives or is located. Now, how did we actually arrive at a service mesh? It really all started with this concept of I have a bunch of microservices, and using things like an Ingress Gateway, trying to do manual TLS between services isn't going to scale very well. Plus, trying to extract any sort of Prometheus-style observability data isn't easy. So we needed something to do this. Netflix worked on a project to create a service mesh-like functionality, but they did so using something called the Envoy proxy alongside Kubernetes. Now, Envoy is a proxy that we'll see as a recurring theme within the Istio service mesh because it is what we call the Sidecar proxy inside of a mesh, as well as it's used in something called the Istio Ingress Gateway. Now, when you're looking at a service mesh, you're going to find a number of key features. I did mention one, which is service discovery. But once we know about these services or these microservices, we also have the ability to load share or load balance between them. So a classic example is I have rolled out version 1 of my application, and I have rolled out version 2 of my application as well. I also have another copy of version 1. Version 2 is just not doing anything at the moment. So all my traffic will go to version 1. Primarily. Now I have 2 copies of version 1. I will use the Istio service mesh to route to both of these versions so I can evenly split traffic. Situations why I might do this is for high availability or resiliency in my services or my application. Also, I might have a globally distributed application where I have, one part, actually version 1 or the copy of version 1 in, let's say, North America, and the copy of version 2 or version 1, or the second copy of version 1, I should say, in Africa, for example. So this may dictate how we get to these services. The other thing too is the service-to-service communication and how we go about securing it. There's this concept of mutual TLS where both ends of the service need to trust each other and then provide an encryption layer for each other when there's traffic being passed. That's something natively offered through the service mesh, through the Sidecar proxy. That same Sidecar proxy offers traffic control so we can direct traffic wherever we want to, and it also enforces policy. Now, it's also an observability point because all traffic in and out of the application has to go through this Sidecar. It collects all this data for us. So now we can use tools like Kiali or Jaeger or even some observability platform like Honeycomb to be able to discern who's talking to who and if there's any sort of latency in the request flow or how long our services are taking to respond. Now, that being said, here's a visualization of what a service mesh looks like. So if you can look in the diagram here, we have app 1 off to the side, and app 1 here has a sidecar proxy next to it. App 2 also has a sidecar proxy. Now, when app 1 needs to talk to app 2, it actually sends its traffic to the proxy. The proxy is the one that's creating what we call an MTLS tunnel or communication over to this proxy over here. And then this is your data plane where the traffic will pass along. Now, that being said, the proxies don't have a lot of intelligence until we come in and program this intelligence. So just like you would interact with the Kubernetes API, you would pass in configurations through that API, and a control plane known as Istio D is responsible for understanding that configuration and then passing that down to the proxies. Now, there's a lot more involved. There's something called the SDS, the XDS data plane, which allows for this configurational data to be passed along the control plane over to this proxy. Given the time that we have, unfortunately, we won't get into those specific details. But if they come up as questions at the end of this, I can definitely answer some more specifics around the XDS capabilities, as well as how that relates to Envoy. Now, like I mentioned before, Istio, the Istio Service Mesh, provides those functions around connection, security, as well as observability. So we can see our patterns of our microservices and understand who's talking to who. Now, to get a little bit more specific, right? Let's assume that this entire box here is oops, sorry, that wasn't supposed to happen. I have a magic mouse and sometimes it likes to shift a little bit. So let's just assume I have a Kubernetes node here. Let's say it's a single Kubernetes node, and quite honestly, we're self-contained. Obviously, you would not run a single node in production. There might be very interesting use cases where you might do that, but in our case, this is just for demonstrative purposes. Now, down here we have Istio D, which actually contains a number of components. You won't see these components as pods anymore inside of, oops, keep doing that. You won't see these components as pods anymore inside of your Kubernetes cluster. You would actually just see something called Istio D, which contains these functions. So just a quick walkthrough, there is a few things that go on with these functions here. The sidecar injector is responsible for being able to inject this sidecar proxy into any one of these services. In a pod, you'll see that there are 2 out of 2 services. The other thing too is that there are other services here that control configuration, service discovery, and even certificates to be able to provide identity to these sidecars. This is what Istio D is responsible for. Now, Service A and Service B communicate using the sidecar proxies, and they gain their information and certificates from Istio D. When we have inbound traffic coming from external to the mesh, meaning I might be a client using my computer, my MacBook, to communicate with a service inside of the mesh, I will use something called the Istio Ingress Gateway to get into the mesh. Now, the Istio Ingress Gateway, if you notice, connecting to a sidecar proxy has a little lock. That lock represents that we're using MTLS from the gateway over to the sidecar. And if this sidecar has any sort of indication that it needs to communicate with service B, that communication stream is all the way protected to this sidecar as well. So it's encrypted using MTLS. Now, there's a few ways we can get into the world of deploying Istio. Actually, let me just cover something else here as well. When I have traffic inbound into my cluster, I will use the Istio Ingress Gateway to communicate with inbound traffic. If I have traffic that needs to leave a cluster, there's something called the Istio Egress Gateway that we can also use to share traffic outbound to wherever the destination might be. This is a filtering mechanism. You can filter outbound traffic. Maybe you don't want certain objects to communicate outbound and you want to lock them to internal to the mesh itself. Now, that being said, there's a few labs that we're going to get into. I don't think we'll be able to get into all the labs given how much time we have, but I want to show you how we get started with a service mesh because you can get very, very granular very quickly. but there are starting points, right? We usually normally have to consider how we would onboard into a mesh or onboard our services into a mesh, because there's a consideration here. If I have to inject a sidecar resource into a running pod, the running pod isn't going to simply just shim the sidecar in, which is just another container, and automatically start it up. We actually have to restart the pod, which means a restart of the deployment or daemon set, whatever we're using. What that means is the application may go offline. So usually when you roll out a mesh, you're doing this in a very incremental fashion. You've got change windows in place or maintenance windows in place. Maybe you have other versions or other copies of your app also responding to any sort of requests that come inbound to mitigate any sort of outages. Now, one strategy is deploying the gateway first. Now you have an entry point into your mesh, and you can use this gateway or the Istio Ingress Gateway to even set up some sort of load balancing mechanism to route between different copies in case you're starting to onboard services. So this could kind of behave like a sidecar for you for a number of meshes, or sorry, a number of services. Now, ignore this URL here. I'm not sure where it goes. I believe this is going to take you to the, I would say, the Academy, but we're not going to use the Academy today. We're going to use an actual Instruct terminal. Instruct is this environment right here. You're going to log in using your web browser, whatever web browser you're using. Obviously, the preferred browser would be Chrome, only because it's got a known working configuration. Other browsers will work. Firefox will work. Not sure about Edge. I've never really tested it out. But that's all you need. You need a browser. You need internet access. I mean, you're already here. You access this webinar through the browser, so you should be able to hop onto this environment pretty quickly. What we're going to be doing is we'll quickly install Istio, and we're going to use the Istio CTL method to install Istio. There are a couple of other methods that you can use. The other methods are more for production usage. And the reason why I'm using Istio CTL is because I'm using this for demonstrative purposes. In real life production, the Istio operator is something that you would use as a config file, which is customized to whatever you're trying to deploy. And then you'll deploy that as part of your automation streams. Or let's say you're using something like GitOps with Argo. You would use Argo to deploy it. You could also use Helm charts to be able to deploy Istio as well, which is another preferred approach for production usage. Now, Istio has a few installation profiles. There's actually one here that you're not going to see right now, which if you join us in part 2 next week, we'll discuss something called ambient mesh. Today, I won't discuss it, but it's a new mode of operation within Istio. We'll be using the demo profile because it's going to give us what we need to get Istio up and running. That's the first part of the lab. And then we'll also see that there are some add-ons deployed as well. And then there are a few other labs that we'll do. So we'll also deploy the Istio Ingress Gateway so that we can actually get access to services inside the mesh. So the Istio Ingress Gateway is secure. I mean, quite honestly, it's the entry point into our environment. There are a few resources that we mess with the gateway, and I'll come in and I'll address that very shortly. But let me, I want to jump ahead very quickly because I want us to get started into the lab environment. So what I'm going to do is I'm going to change my environment to the terminal. You all should have access to the terminal as well. If y'all can just drop a quick thumbs up or something to show me that you have access to the terminal, we can go ahead and get started. While I'm doing that, there is a question from Muhid. What's the difference between a service mesh and an ingress? So an ingress resource is something native to Kubernetes, which actually has evolved into something called the Gateway API spec. The ingress resource traditionally allowed you to route to different services on the back end, but it was quite limited in how you can enforce things like TLS and special types of routing to the different destinations. The other thing too is that it was more of a fixed resource, so it wasn't truly customizable. And then you also had to bring your own ingress controller as well. The gateway resource or the gateway API is an evolution of that, which now allows you to do some very interesting load balancing, some very interesting HTTP routing. It does allow you to enforce TLS as well. But then at the same time, even then at that point, you'll still need a mesh because your services need to be secure when they communicate with each other. Can you all hear me? Simon, can you hear me? It just said my mic was unplugged for some reason. Oh, looks like I should be good. In any case, once you're inside the mesh, one of the challenges inside the mesh is that you now have access to be able to do east-west traffic. And when you do east-west traffic, or when you have east-west traffic flowing, your gateway isn't involved or isn't in path of that traffic anymore. So this is where the sidecar resource of the service mesh becomes extremely valuable. All right, let's just get into it right now. So what we're going to do is we're actually going to download Istio. So in your control plane, or sorry, in your instruction panel, you should be seeing a curl command there that just installs Istio CTL. Now, the current version of Istio that is out is 1.16. I know we're using 1.12.1. I'm not here to demonstrate what's different between the two versions. I'm here to demonstrate to y'all functionality of how Istio works. So this should all be the same, whether you're using 1.12 or 1.16. But for the sake of this environment, just so that we can ensure things are working, 1.12 is going to be used. So when you copy it, you can go ahead and hit enter. And then there are a few things that go on just to make sure that Istio CTL is downloaded. Here's another thing I'll quickly run for y'all. So if I do a kubectl get nodes, you'll see that there is one single node in the cluster. And if I do a kubectl get pods, you'll notice that there are no pods in the cluster. And if I do a -a, you'll notice that it's quite limited at the moment. So there isn't much. We don't have any applications. It's a single node environment. And we're going to go ahead and do some things right now with Istio. So let's go ahead and change into the Istio directory that we just pulled down. And one last thing we're going to do is we're just going to export our path so that we can actually have access to Istio CTL in any directory that we're in. So if you just type in this command, this will just tell the terminal or your bash terminal where Istio CTL is. So even if I did a cd this and I did Istio CTL, it should work just fine. So let's go ahead and just run an Istio CTL. Yeah, my mic keeps unplugging, so I apologize if I suddenly disconnect audio. I'm not sure why that's going on. Simon, can you hear me still?
Yes, absolutely. I will definitely ping you when it doesn't able to.
Awesome, thank you. All right, so we are verified that we're running the version of Istio 1.12.1. One thing we're going to do is we're going to do the Istio CTL pre-check just to make sure that there isn't a version of Istio already installed in our cluster, and we're ready to go. The other thing too is let's list out the profiles, and I'll briefly review them again with you. There are a few profiles here where if you set the default, it basically only deploys a very few set of components like Istio-D, and that's about it. There are other profiles here where you can customize. For example, if you want to customize how Istio-D acts, then you can come in here and use the empty profile, but then you'll have to specify an additional configuration. In our case, we're going to use the demo profile. So if you type in istio-ctl space install space -- set -- profile equals demo, and then say -yes, what ends up happening is it'll go on to deploy Istio-D, the Istio Ingress Gateway, and as necessary, I believe the Istio Ingress Gateway into the cluster as well. And then we're pretty much good to go. Like Istio is running, but there are a few things that we probably also want to do, like deploy the sample add-ons, just so that we can get a sense of what's going on in Istio. While Istio-D is installing, I'm going to double check the chat here and see if there are any questions that have come up. So how do we configure in Istio-D? Now, you're not necessarily configuring Istio-D in the demo profile, But the way you would configure Istio-D for your own usage is you're actually going to mess around with the Istio-D operator, or sorry, the Istio operator configuration. There's documentation on the istio.io website that tells you and gives you actually a basic YAML configuration for the Istio operator that you pass along when you deploy Istio using the istioctl command. In that operator configuration file is where you'll come in and specify any sort of details that you want. Let's say you're trying to change the format of how you're doing, let's say, tracing from Jaeger to Zipkin or something along those lines, or you want to point to a special collector or specify a Zipkin collector. That's where the Istio operator configuration comes into the mix. Okay, so Istio-D should be deployed, or Istio in general. What we'll do also is deploy the sample add-ons. So there's a command that follows. Actually, before we even run that command, I want us to verify our install. So we can do an istioctl verify install. And it'll just tell us if everything's going well, and we'll see all the different CRDs that have been deployed and other objects as well. Now, what we want to do is we want to deploy the sample add-ons, but if you recall, I actually exited the Istio directory, so I want us to change directory back into that, and then we're going to run a kubectl apply-f samples add-ons. And it'll just deploy some key components for our observability tools. So if I do it, I run a kubectl get pods -n Istio system. What you're going to find is our Istio-D has been deployed. We have a load balancer pod, and this is just to mimic load balancing capabilities for our Istio Ingress Gateway. That's going to service this Istio Ingress Gateway object along with this Istio Ingress Gateway object if we decide we wanted to allow this to use that as another exit point. But for now, it's only tied to the Istio Ingress Gateway. You'll also see there are 4 components here deployed: Grafana, Kiali, Prometheus, and Jaeger. I'm sure the majority of you are familiar with what Grafana is and what Prometheus is, but Kiali is a visualization of your request flow between services. Jaeger will tell you and show you the different traces and the spans within the trace. So what is a trace? A trace is actually a request flow from your host or your host client all the way to your actual destination service. But here's the thing. To get to that final service, to actually give you a response, there are services in path that need to be hit up before you get that response. So Jaeger will actually tell us all these different spans, and it'll tie these spans together using the B3 header ID, which kind of see a little bit of. So we can also go ahead and enable the few different dashboards here. So you can use the istioctl command to expose, let's say, the Prometheus dashboard, and you may not see the Istios. Actually, it may not show up for you. Or it may show up for you, but ideally, the browser that shows up, or the UI that ends up showing up, is just the standard Prometheus UI. There are a few other browsers that we can end up seeing, but quite honestly, I want us to actually visualize traffic, and we can see that through the lens of Kiali and Jaeger in the next module. That being said, if you're done, you should have reached the end of that module. I am at the end. I'm not going to expose the other dashboards. There's no need to. Go ahead and hit check, and it should take you to the next module. The next module is where we're going to deploy an app and expose it using the Istio Ingress Gateway. And in the meantime, I'm going to quickly look at the questions in the chat. There's a question here. Is Istio just for creating mutations? No, it's not for just creating mutations. And if you mean mutations in the sense of creating basically modifying the pod to be able to inject the sidecar, then no, it's not just doing that. Istio is there to provide the traffic management using the sidecar proxies that it has injected. It uses the mutating admission webhook controller to be able to inject the sidecar because it's modifying a resource. So it needs authorization to do so, and it has been granted that permission from within the Kubernetes environment. All right, so now that we've pretty much started our next lab, let's go ahead, or the next module, let's go ahead and deploy the Istio Ingress Gateway. So we need to get to the root folder. We need to get the Istio workshops. We need to get to the Istio basics. I'm not in the right folder, so let's go do ls. There's Istio workshops. Here we're going to deploy the Istio Ingress Gateway and sample application. The sample application is the standard book info application that basically allows us to see what's going on in the environment. At the same time, it allows us to, I'm actually going to pull up another window here so you can see the UI when I have it available. But it also allows us to, what was I going to say here? The Istio Ingress Gateway allows us to expose apps, basically. But in our case, we're exposing book info because we need an entry point to book info. So I'm going to go ahead and change into Istio basics. Just see if it's all there. All right. My sample application is ready to go. What we're going to do is we're going to create a namespace we're going to deploy the application into. So we're going to call it Istio in action. And if I did a kubectl get ns, you're going to see that there is an Istio in action namespace. Now, what we're going to additionally do is we have a bunch of apps in the sample apps folder. So if I do a cd sample apps, or actually if I do an ls sample apps, if you notice here, there are 4 YAML configuration files. We definitely don't want to deploy everything here. So what we're going to do is we're going to run a kubectl apply -n. And actually, you should have an automatic copy and paste. In fact, I do. So I'm going to use it as well to simplify. But it'll go ahead, deploy the service account, the deployment, and the service itself so that all of these apps can be exposed. But let's take a look at something. We'll do a kubectl get all -n Istio in action. And if you notice here, right, now all my pods are running. The service types are all set to cluster IP. The deployment artifacts are telling us that everything is running and everything looks good. Notice here, though, we're only using cluster IP to expose these services, meaning these services are only internally accessible. What I can do is I can exec into, let's say, the sleep pod and make an exec call to the purchase history or the web API service, but that's all I can do. I can't do this externally. So the only way to do this externally is to effectively expose it using the Istio Ingress Gateway. Now, if we do a kubectl get svc-n Istio system, we're going to see that our Istio Ingress Gateway here has an external IP. We're going to use this external IP to access this application. But wait, how do we access this application? We have no sidecar. We have no route to it. This is where we're definitely going to need to take advantage of, using the Istio Ingress Gateway as well. Now, we haven't quite deployed the Istio Ingress Gateway, but what we're going to do is we're going to store some of this Istio Ingress Gateway port information and IP information as environment variables. And the reason why that is because we're going to come back in and we're going to access the app using its gateway IP and currently the unsecure port 80. And then we can come back later on and access it using TLS with the secured port. So even if you curl to it right now, it will not work. Now, there is a file that we need to deploy. If you actually follow below, there is a copy paste command that'll output the web API gateway YAML configuration. Let's look at it quickly. So this is an abstraction resource that abstracts the Istio Ingress Gateway. What it's doing is it's telling the Istio Ingress Gateway, hey, I'm going to look for any gateways with the label Istio Ingress Gateway. Hey, I found you. 2, I'm going to listen in on port 8080 for any HTTP bound traffic directed towards istioinaction.io, which is a host. So this host, if I make a request to it on this port, which is the standard HTTP port, the Istio Ingress Gateway is going to listen in on it. Now, that's all I'm telling the Istio Ingress Gateway to do. Listen in on this port at this host. That's it. Whoever responds to the host, quite honestly, it should be every host or every node in the Kubernetes cluster. They should respond to this address. That's exactly what's going on here. But I haven't finished the rest of this equation. The other thing I need to do is, if you scroll down a little bit, there's also something called a virtual service resource. So the virtual service resource is more like a routing rule set. It's basically saying, how do I map, when I receive a request outbound from the external world, how do I map that request to something inside of the cluster? Well, guess what? Let's look at this. If I am listening in on my Istio Ingress Gateway, which is called the Web API Gateway, my virtual services, this is the gateway I'm listening in on. This is the host I have to listen for. So if someone's making a request to this host on port 80, well, it's because the request is coming in on this Web API Gateway, because this Web API Gateway is using the Istio Ingress Gateway, I now know that I have to route it to webapi.istioinaction.svc.cluster.local. Hold up a second. This is a Kubernetes DNS address, meaning I've mapped it to a service inside of the Istio Inaction namespace, which simply, if we go back up here, is this service right here. This is the service I mapped to, because guess what? It's in the Istio Inaction namespace. So this is the service I am routing to. Now, this service is mapping to port 8080 on the container side. So it's just going to listen on port 8080 on the container port. That's all that's going on here. But when my client, my host client, makes a request on port 80 to this host, because of this virtual service routing rule, says go to this Kubernetes service in the Istio Inaction namespace. That's all that I'm doing here. It's a relational setup here. So this right here is related to this host, which is tied to this gateway abstraction instance. This gateway abstraction instance is tied to this Istio Ingress Gateway resource, which we saw earlier on. And that is tied to this port it's listening on for this host. Now we have to deploy these resources. So we can also go and inspect the port number that's assigned to Istio Inaction's Web API, but I just explained that. But let's go ahead and apply these particular resources. You could do so either calling out the specific YAMLs in the paths, or you can just use this command that I have on screen here, kubectl-n inaction, Istio Inaction, apply-f, and the sample apps /ingress directory. This will go ahead to deploy the two resources. So if I do a kubectl get virtual service, I have to also specify the namespace -n Istio in action. And we see that my virtual service is deployed, which is using the Web API Gateway, which is listening in on that host. If I do a kubectl get gateway -n Istio in action, I will see the Web API Gateway deployed. At this point, if I curl this app, because I'm already, I'm going to go ahead and curl Istio in action. And at the same time, I've already, specified environment variables for the external IP and the port that I'm listening on for the Istio Ingress Gateway. I should get an HTTP 200 success code, which I did, which is telling me at this point that my Istio Ingress Gateway has opened the door for requests made to istioinaction.io that is going to be directed towards the Web API service. Questions? Are there any questions about that?
No, Mourinho.
Excellent.
Haven't anyone.
Excellent. Okay. All right. So there's a few things that we can also do. We can use Istio CTL to view the routes to this service as well. So there's a command there. If you run it, it's called Istio CTL proxy config routes. And then on the deployment itself, it actually tells us the virtual service and the host that we're listening on. And pretty much we're matching on any destination because we haven't specified any backend paths. There's only one place we're going to, which happens to be the web API service. But that's the route. If you actually think about it, this is a routing table. And if you see here, these are wildcards that just say go to any resource. In our case, we have a wildcard on the destination path, which means go to any path, which will only be one path at this point. We can also individualize the route a little bit and see a more specific route in JSON format going over to the web API Istio in action service. What we're going to also do now is we're going to try to inject this certificate using the secret service here in Kubernetes. So there's a command here that's going to call on local certificates that we've deployed in a folder. So we're going to use the kubectl create secret command, and we're going to use a TLS type secret where we're going to give it the key of this particular key. And the certificate is also located here in this location. Once the secret's created, what we need to do is we actually take this secret and assign it back into the gateway, because now we can tell the gateway to listen in either on the unsecure port or the secure port. So let's go ahead and do that. If we actually go ahead and look at the updated gateway configuration, we can even see here, right? Based off of the previous one, we didn't have this section here, which is the TLS mode. We also didn't have the port set up to be HTTPS and the number being 443. That's all that's changed here. We've changed the listen port, and we've changed the fact that we're now listening. We're actually looking for a TLS cert that we have to pass as a header when we make that curl request. So if I go ahead and apply this, right, this means that my curl request will no longer work without the certificate. See that? My gateway has been updated, and it's now looking for a certificate. Now, the way around this is if we actually pass in the certificate. So I'm going to curl, and I'm going to pass in my CA cert, which is the same cert that I actually assigned to the gateway using the secret creation. This is the host that I'm targeting, and it's actually going to go to the 443 port, or port 443, which is the secure port. And it's going to go ahead and resolve this to an IP address as well, just so that it translates it when we process the curl request. Now, because I am passing in the request, this actually will work. And there's my success 200. Now, at this point, we're at this point where we're seeing traffic pass through the mesh. At the same time, there might be this point where we want to see what's going on in Grafana. So let's go ahead and take a look at Grafana here. Let's do a quick refresh on the Grafana UI. And now we can see all the traffic coming in from the default namespace in our Kubernetes environment, as well as traffic directed towards any of these particular, can't find that. It hasn't built the dashboard, I guess, but towards these given services. Now, we don't have much traffic going on other than the curl commands that we ran, but you'll see more traffic come in. In fact, we want to visualize it differently. We just don't want to see the requests per second. We also just don't want to see the 400 success or the 400 codes for any sort of redirection or anything like that, or client side issues. But at the same time, we want to be able to see success codes here. We also can visualize this using Kiali. So we'll do that in the next module. So go ahead and hit check. And we should be able to move on to lab number 3 or module number 3. And I'm going to relaunch my terminal, or I'm just going to clear my screen. Let me see if there are any questions here, which there aren't. Okay, we're good. All right, let's start the challenge. Okay, so this is where we're going to go in and add, sorry, give me a second. I've been talking nonstop. You need some water after a bit. All right, we're going to move to the sidecar injection right now. And for the sidecar injection, we actually have to do something here. We have to label a namespace. So we're labeling the Istio in action namespace with the Istio-injection equals enabled label. The moment we do this, we're telling Istio D and the Istio D's sidecar injector to look for namespaces with new workloads that have been deployed into the namespace to trigger a sidecar injection. So when I do this, if I do a kubectl get ns -- show labels, notice how all these other namespaces don't have this specific Istio injection equals enabled label. This now means that any new object deployed into the namespace will get a sidecar. But if we do a kubectl get pods -n Istio in action, oops, I might have actually notice that we're still sitting at 1/1 inside of the namespace here. That means that we haven't injected the sidecar. Now, one thing, I'll be very brief about this because there's a lot of information about the sidecar injection and what needs to go on. But one key thing to be aware of is that you'll need access to the netadmin security capabilities because traffic redirection needs to occur for traffic to leave the main application container and go over to the sidecar, which means we're having to rewrite some IP tables rules here so that traffic always goes to the sidecar versus going direct and leaving the exit point of the pod or its interface to get out to, let's say, the rest of the pod network. We want it to go through the sidecar because the sidecar and the main container share the same networking namespace. This is why we have to set this up appropriately. Now, let's go ahead and take a look at something here. We're going to take a look at this deployment artifact here, and I want you to notice something very important. The deployment artifact only has a reference to one container. This is going to change when we re-roll out the deployment here. And the reason why it's going to change is because we're rolling out a sidecar, and you're actually going to see two more containers show up here. The interesting thing, though, is that all the other applications in this namespace kind of share the same setup as well because we haven't injected the sidecar. Now, what we're going to do is we're going to roll out the sidecar by rolling out, restarting the deployment using the rollout command. So if I do a kubectl rollout restart deployment for my web API, which I'll also do for my other services as well eventually. This means that now my services or my web API service will have a sidecar. So let's take a look at this. kubectl get pods -n Istio in action. Istio in action. And if you see here now, this web API pod has 2 out of 2. That's interesting. That's super interesting, right? It's because if you'd go ahead to describe the container, right, which we can do a number of different ways, or we can even output the YAML of the container, that configuration now has changed drastically because obviously the container is running or the pod is running. But if you look here, right, let's start at the spec section here. So we have one container here. This is the main container, the main application container that is running. This is nothing different than before. But if we scroll down a little bit further, okay, if we look down a little bit further, I'm not sure why my mic is doing that again, but we will see another container image. Let's find it. Let's look for it. Here we go. If you see this, right? And it's under which field? Where are you? There is one container. There's web API. I'm looking for the second name. There should be another name somewhere here that says, here we go. This is the Istio proxy, right? This is the actual sidecar here. And then let's scroll down one more time. And you see this init container here? This init container launches first to the traffic redirection set up the appropriate user groups. It needs access to netraw and netadmin so that it can do the traffic redirection. Once it's done, it actually, the init container goes away, and then the sidecar runs. But notice the init container is still using the proxy v2 image, which is the sidecar proxy image. So there's nothing special here about that init container, other than the fact that it is using the proxy v2 sidecar image, and it's just doing a bunch of redirectional traffic or redirecting of traffic. Now, what we're going to also do is we're going to go ahead and re-roll out the other deployments. There is a section here that if you're looking in the instructions, it'll tell you to go look at all of the flags of IP tables, but we're not going to get into that right now for the sake of time. I want us to just see how these other services are being restarted and how, if I do a kubectl get pods in action, Istio in action, you see that the original pods are being terminated. This is important because that means that these pods are going offline, which means that these services become unusable temporarily, but then their equivalents come online very quickly. But notice now they all have 2 out of 2, which means all of them are running the sidecar resource. Now, at this point, if I curl from my host still to the Istio in action host, or to the actual service, it'll still work, right? And the reason why that is because I haven't implemented any sort of secure policies yet. All I've done at this point is I've effectively deployed the gateway. I've deployed my app. I've deployed the sidecar resources for these apps or these different microservices. And now I'm operating a true mesh. But I haven't turned on something called mutual TLS yet. I also haven't set up any sort of authorization policies to allow service A to talk to service B and service B to talk to service C. These are things that we would do just to get to that production environment, because now we're trying to get to this element of zero trust. All right. So before we hit check on that, I want to show you one thing. So if you actually open up, this is the wrong one. Hold on a second here. Okay. So if you open up the Jaeger UI, right? And if you just select your web API service, and if you just hit find traces, you will see that there's a trace here. And this trace is telling you, hey, there is traffic coming in on the Istio Ingress Gateway. That traffic is now directed to the web API in Istio in action, which is now sending this to the recommendation service, which is now communicating with the purchase history service and providing responses. So for you to get your response, guess what? I have to pass through all these services to get to purchase history to give you the answer. That's important, right? But how these are all tied together is something called the B3 header ID, or the B3 trace header, which basically says, if I have a set of spans, right? Look at this. This is a span, this is a span, this is a span, but this entire thing is a trace. All these spans need to be tied together to form this trace. That B3 trace header ID is what ties all of these different spans together to give you this trace. Let's go ahead and hit check. We're going to do one more module, and we are going to call it, because we are almost out of time. I'm going to take a quick peek at the questions here. No questions? All right, this is good. So in this next module, right, we're actually going to, what are we going to do here? Okay, we're going to go ahead and we're just going to secure the communications within Istio, meaning we're going to turn on pure authentication. And all that really means is we're enabling true MTLS here. So what we're going to do is we're going to change directory into the Istio basics folder, which we already should be in. And we're going to get our pure authentication configuration, which basically says, do we have any MTLS running right now? We don't. So all traffic is communicating clear text or plain text outside of the mesh or inside of the mesh. Outside of the mesh, in order to communicate, I still have to pass in MTLS. So you will see a command block here, which does an EOF configuration or just passes in the file or the YAML configuration in line. We're basically turning on something called pure authentication, and we're setting the mode to strict. The strict mode means if I am communicating with you and you are communicating with me, we both need to have MTLS enabled. That means I can't communicate with you if you don't have a sidecar. You don't have a sidecar? Sorry, buddy. We're not talking, is effectively how this is going to work. So now I'll go ahead and enable pure authentication. I'll verify that it is deployed. And now that I've verified that it is deployed, we should be able to send some traffic, but we need to deploy a pod, right? So let's deploy a pod in the default namespace, and it's called the sleep service. This is a service that's going to live outside of the mesh, even though it's still in the same cluster. It's outside of the mesh because it doesn't have a sidecar. We're going to actually exec into the pod, and we're going to curl the web API application. What do you think is going to happen? Any guesses? If I try to access a service in another namespace that's outside of the mesh, this should fail. And like we see, it does fail. And the reason why that is because the sleep pod, if we do a kubectl get pods dash, or just get pods, it only has the main container running. So let's actually take a look at some enforcement and visualization of Kiali inside of, let's take a look at how our communication is going on inside of Kiali. So we're going to visualize some of this. We have the Kiali UI up here, right? Let's go back to our terminal as well, and we'll run this for loop here, which is going to make about 200 curl calls, which we can ignore, and that's fine. But if we come in here, right, it's now loading a graph. In fact, let me minimize this a little bit, and you should be able to see this full graph, and we can zoom in and see how our traffic is coming inbound into the Istio Ingress Gateway and over to the different services. Now drop that display drop down, and let's set up traffic animation, and let's click on security. Now, what we're going to notice here is that we're actually seeing that traffic is passing from the Istio Ingress Gateway over to Web API, the service, and over to the pod. And now this pod needs to communicate with this service, which is tied to this pod. But if you notice the lock icon, it's saying that we have MTLS in place, it's enabled. And if you look at this, right, the SPIFFE ID of the Web API service account and the SPIFFE ID of the recommendation service account is in that MTLS tunnel there, meaning mutual TLS is active, it's running. The communication between these two is secure. So interestingly enough, like I'm going to stop here, right? Because I actually want to just wrap up here. Interestingly enough, we have verified that now traffic is encrypted inside of our mesh. Now, there's so much more we can dig into, right? We're not going to be able to get to all of it. But what I want to point out here is that the service mesh here does a number of things. We saw some traffic routing through using the Istio Ingress Gateway. We saw some visualization, which we're seeing right now using Kiali. Guess what? The sidecar resources are sharing this information to Kiali to show us how the traffic is moving. We're also witnessing that security is in place from an encryption standpoint. What I haven't shown you is zero trust, because there's some more bits to zero trust, meaning we would actually have to implement an authorization policy that simply says Web API can only talk to the recommendation service, and the recommendation service can only talk to the purchase history service. But the Web API itself cannot directly talk to purchase history. If that were to occur, the request would be blocked. And we do this at the HTTP layer using something called Istio authorization policies. I will stop there. You are all welcome to continue going on in the lab. You'll get to go into the authorization pieces. You'll get to go into the bits and pieces of traffic routing and management and doing canaries and deployments and whatnot. But I wanted to leave you with a taste of how to get started with Istio and how to get going and how to continually keep going. Because right now you have the momentum, you have the workshop open. Please continue to run the workshop so that you can get to the very end. At the very end of your workshop, when you're complete with all of this, you will have an understanding of how Service Mesh works from the lens of traffic management, observability, and security. You'll understand how the Sidecar works. You'll also understand how to do traffic routing using virtual services and even destination rules, which then allow you to set different tags and different weights for the different versions of your application. Let's say you have version 1 and version 2, and you want to send 50% of your traffic to version 1 and 50% of your traffic to version 2. This is what this workshop will continue to explore. I am finished now. I'll pass it back to you, Simon, for any last words.
Thank you, Mourinho. It's been a wonderful. Ahmad Chaudhary is saying is a very insightful. Thanks to Mourinho. It's a great and few questions I have in my mind. But first, tell us who is actually behind that playground. We can shout out to people who have created this wonderful workshop for the community because it's been missing. Like if when I started learning about Istio, there's not such playgrounds. So it's very difficult for me to set up environment for us. So it's been everyone who created this workshop has been a thumbs up. Thank you very much for a wonderful curated workshop.
Yeah, I'll drop a few shout outs to Lynn Sun, who is our director of open source here at Solo, and Nick Nellis, who is one of our principal field engineers who does so much for customers. And this was born out of the need for customers wanting to better understand how Istio works. But the best part about this is while I gave you the direct instruct access, there's something called academy.solo.io, right? You can go and take this same workshop as many times as you want. Even though I gave you the instruct link that gives you 2 more tries, go to the academy. You'll get a much more deeper sense of how all of this works, because you also will get slide material that goes through the entire gamut. One last thing I'll point out is we have a number of different resources for you. If you have questions about how any of this works, come visit our Slack. It's at slack.solo.io. We're here. Like, it can be as simple as, how does Istio-D function? Or what is Istio-D? Or why even Istio? Or I'm trying to build out this very resilient microservices environment. Can you help me build out some virtual services? And we can give you examples, right? We'll go as deep as that if we need to. But the answers are here. If you need us, we're right here for you. Simon, I just want to say thank you so much. This is part 1. Part 2, for those that are still here, part 2 digs into another mode of Istio called ambient mesh, where we actually don't use the sidecar anymore. So we'll get to dig into why that might be meaningful for your own projects at work as well. And I hope to do this next week. Thank you, everyone.
Yes, Mourinho, absolutely. Thank you very much for your time. And we will be meeting again next week and we will cover ambient mesh. That's a new one because I'm taking an eye out on how to remove the sidecar and do all these kind of stuff with it. But it's been a wonderful session for me. And also, I hope this will be a go-to learning resource for everyone who are watching us. And it will be stay on the YouTube. So I'm very, very hopeful this workshop gains so much momentum, so much views, and so much appreciation after everyone watching and log into our YouTube channel. So it's all thanks to the Mourinho for the wonderful curated of workshop we have for the Solo. Thank you very much for curating the playground and wonderful explanation of very tough concepts. But when I watch Mourinho, it looks very simpler to understand. So Mourinho, once again, big thumbs up for you. And we will be meeting again next week on the same day, on the same time for the next workshop. Thank you, everyone who stay up to still at the end of this workshop. Stay happy, stay healthy, stay safe. Bye bye.
Bye, everyone.